Hi everyone and welcome to smartalexcoaching. This is the second video on how to rationalize denominators, and in this video we're going to be looking at how to rationalize binomial denominators. The key idea we use when we rationalize a binomial denominator is to multiply by its conjugate. Here are some examples of conjugates. What I want you to notice here is that all the terms are the same. The only difference are the signs. For example, the first one, we've got root 3 plus 1. Its conjugate is root 3 minus 1. One is a plus and one is a minus. The second one, we've got 2 root 5 minus 3. The conjugate is 2 root 5 plus 3. Once again, the differences are in the signs. The third one, we've got root 2 minus root 3. The conjugate is root 2 plus root 3. And the last one, we've got 4 root 3 minus 2 root 5. And so the conjugate is 4 root 3 plus 2 root 5. So now you may ask, how does multiplying by the conjugate help to rationalize the denominator? Well, we use the difference of two squares identity, which is given by x plus y times x minus y is equal to x squared minus y squared, and the fact that root x squared is equal to x. So if we've got root a plus root b, which is a binomial denominator that is irrational, if we multiply that to root a minus root b, its conjugate, we're going to get root a squared minus root b squared, which simplifies to a minus b, and a minus b is in fact rational. Let's now look at some examples on how we can use this idea to help us rationalize the denominators of the following expressions. For the first one, we've got 1 over root 3 plus 1. So what we're going to do is we're going to multiply the top and the bottom by the conjugate of the denominator, which is root 3 minus 1. And we need to multiply both the top and bottom by the conjugate because this here is effectively equal to 1. And we know that when we multiply anything by 1, the expression is preserved, it doesn't change. So we multiply this out and we're going to get root 3 minus 1 over root 3 squared minus 1 squared. And notice that this is the difference of two squares identity. We're now going to get root 3 minus 1 over 3 minus 1, which is simply root 3 minus 1 over 2. And now we have got a rational denominator for this expression. So for b, we've got 2 over 3 root 2 minus 4. We're going to do the same thing. We're going to multiply top and bottom by the conjugate. So 3 root 2 plus 4. And when we multiply this out, we're going to get 6 root 2 plus 8 over 3 root 2 all in brackets squared minus 4 squared. This is going to give us 6 root 2 plus 8 over 9 times 2, which is 18, minus 16. This simplifies to 6 root 2 plus 8 over 2. And we can simplify this further to get 3 root 2 plus 4. And again, we've got a rational denominator. In this case, it is 1, and we don't need to write that down. In these next examples, we have two surds on the denominator, but the strategy for rationalizing is still the same. We're going to multiply top and bottom by its conjugate. So for the first one, we've got 1 over 3 root 5 minus root 2. We're going to multiply both top and bottom by 3 root 5 plus root 2. And this, we're going to get 3 root 5 plus root 2 on the top. And on the bottom, we have 3 root 5 all in brackets squared minus root 2 squared. And this will simplify to 3 root 5 plus root 2 over 45 minus 2, or 3 root 5 plus root 2 over 43. For the second one, we've got 4 over root 8 minus 2 root 3. So we're going to multiply the top and the bottom by root 8 plus 2 root 3. This is going to give us 4 root 8 plus 8 root 3 over root 8 squared minus 2 root 3 all in brackets square. That's going to give us 4 root 8 plus 8 root 3 over 8 minus 12. which is 4 root 8 plus 8 root 3 over negative 4. And we can simplify this further to give us negative root 8 plus 2 root 3, or simply 2 root 3 minus 2 root 2. In the next examples, we have got surds both on the top and the bottom, but because our aim is to rationalize the denominator, we continue to multiply the top and the bottom by the conjugate of the denominator. So for the first one, we've got root 3 over root 5 plus 1. We're going to multiply the top and the bottom by root 5 minus 1. This will give us root 15 minus root 3 over root 5 squared minus 1 squared, which simplifies to root 15 minus root 3 over 5 minus 1, or simply root 15 minus root 3 over 4. For the second one, 4 root 3 over 3 root 8 minus 11, we multiply the top and the bottom by 3 root 8 plus 11. This is going to give us 12 root 24 plus 44 root 3 over 3 root 8 in bracket squared minus 11 squared, and this will simplify to 24 root 6 plus 44 root 3 over 72 minus 121. And simplifying this further, this will give us 24 root 6 plus 44 root 3 all over negative 49. In this last type, we have got surds both on the top and the bottom, and not only that, both of them are also binomial terms as well. But because we want to rationalize the denominator, we continue to multiply both top and bottom by the conjugate of the denominator. So for the first one, root 3 plus root 2 over root 5 minus root 3, we're going to multiply the top and the bottom by root 5 plus root 3. And we've got to expand that slowly and carefully. This is going to give us root 15 plus 3 plus root 10 plus root 6 all over root 5 squared minus root 3 squared. And simplifying this, we'll get root 15 plus 3 plus root 10 plus root 6 all over 2. For the second one, 2 root 2 minus 3 root 5 over 3 root 2 plus 2 root 3, we'll multiply top and bottom by the conjugate, 3 root 2 minus 2 root 3. And take care in expanding. We're going to get 6 root 4 minus 4 root 6 minus 9 root 10 plus 6 root 15, and all over 3 root 2, all in brackets, square, minus 2 root 3 squared. Now we can do some simplification for the first term. 6 root 4 will simplify to 12, minus 4 root 6, minus 9 root 10, plus 6 root 15, all over 9 times 2 is 18, minus 4 times 3, which is 12, and all of these will give us 12 minus 4 root 6 minus 9 root 10 plus 6 root 15 all over negative 6. So that was a very comprehensive video on how to rationalize denominators. If you did find it helpful and you think others may benefit from it, please share it, leave your comments below. We do release videos every week on various maths topics, and so if you are interested, please help us by clicking the subscribe button below. But for now, thank you for watching. We'll see you in the next one. Bye for now.